4.5, multiplying and dividing by constants. So remember to write the date. Remember to write your name, Tara. And remember that this lesson is brought to you by Bob Ross. There are no such things as mistakes, just happy accidents. Before we get into the nuts and bolts of how to multiply and divide by constants, let's just remind ourselves what a constant is. 3, this is a constant. No variable. Or if we're real mathematicians, we know that the variable has the exponent 0. 3v0 is just the same thing as 3 times 1, which is just 3. If you didn't follow that, don't worry about it. And not constant is one that has a variable. So 3 in this scenario is a constant, whereas 4a is not a constant. So what we're going to be doing is we are going to be distributing the constants throughout all the terms. What we need to remember is, I'll get to that one later, that the numbers multiply by the numbers. Next lesson we'll talk about the other things, if we multiply with something with a variable, how that affects it. But just remember, we're just, when multiplying / dividing by a constant, we're just dealing with coefficients. So remember, coefficients are the numbers that are in front of the letters. So the solution to A, 3 times 4a, you deal with the numbers first. 3 times 4 is 12, and there's nothing to multiply the a by, so it's just 12a. The answer to B, we need to distribute using Bob Ross's Happy Little Rainbows. Okay, so the 5 gets multiplied by the 7x gets multiplied by the 5 just as the 2 does. So if I were to write my next step, I would say 5 times 7x plus, and the reason why we have plus is because that's the thing that is separating the two terms in the brackets, plus 5 times 2. 5 times 7 is 35, and we can't forget that x, plus 5 times 2 is 10. Done. What about C? C is a little bit more complex. The first thing that I want to do is I want to switch the order, because I'm noticing that I have x squared plus 3x minus 5 times negative 4, not just subtracting 4, but it's multiplied because it's in brackets. Okay, what I want to do is, I feel more comfortable with the constant out front, so I'm going to just change the order. And I can do that, because if I go 3 times 5, that's 15. And if I change it, 5 times 3, that's still 15. So with multiplication, it's called commutative. It's the same either way. So I'm going to just change the order here. My negative 4 times x squared plus 3x minus 5. So what I'm going to do is I'm going to draw these happy little rainbows to all of the terms, and there are 3 terms in this bracket. Now I could skip this step. I could skip the, you don't have to write this down, negative 4 times x squared plus negative 4 times 3x minus, because the minus here, negative 4 times 5. Okay, you can skip this. You don't have to write this down. If you like writing this down, please pause right now and write down that line. you can go straight into negative 4x squared. Negative 4 times x squared is negative 4x squared. Minus 12x. Negative 4 times 3x is negative 12x. Minus negative 4 times 5 is negative 20. I want to fix this up though, because I have two signs butted up against each other. So that's going to be negative 4x squared minus 12x plus 20. Now you're noticing that, oh, and this is my final answer. I know some of you are like, what? That's my final answer? And I'm going to say yes, that is your final answer. You'll notice that I have them set up in decreasing degrees. So the term of degree 2 is first, then the term of degree 1, and then the constant or the term of degree 0. Let's divide. The most helpful way for me to divide is to split the question up into terms. Now in this first one, it's really easy. There is only one term that's being divided. I would say 15x divided by 3. Well, 15 divided, and we just deal with the number bits. Oh, sorry, 15x squared. 15 divided by 3 is simply 5, and my x squared, like that. Finished. But what happens when you have two terms? So I would write this as 6x squared minus 4x. So I would say 6x squared divided by 2 minus 4x divided by 2. The next line here, 6x squared divided by 2. 6 divided by 2 is 3x squared minus 4 divided by 2 is 2x. And that is my final answer. I'm going to put a box around it. The reason why we have whole numbers out here is because 2 divides evenly into 6, and so it divides evenly and it's 3. However, it is possible to have a coefficient that is a fraction. So if for example you have 20x squared divided by 40, 20 divided by 40 is 0.5x squared, or 1/2 x squared. That's just a side note, but I just wanted to let you know you could get fractions as coefficients. Last but not least, let's deal with our 3 terms. Now what we want to do is we want to make sure that we apply this division to all 3 terms. So I'm going to split it up into the 3 terms. Negative 20a squared divided by negative 4 plus 16a divided by negative 4 minus 4 divided by negative 4. So then our next line would be negative 20 divided by negative 4, which is positive 5a squared, plus 16 divided by negative 4, which is negative 4a. You can keep that in the bracket. Minus 4 divided by negative 4 is negative 1. Now this is a little bit tricky with all the negative signs, but we'll work it out. So we know that when we have two signs butted up against each other right here, positive and a negative, it's going to become a negative. And we have two negatives beside each other, which becomes a positive. So if I had to rewrite this, 5a squared minus 4a plus 1. I'm going to put a box around it because I like my teacher. So, in summary, when dividing and multiplying polynomials by a constant, just the coefficient changes. And remember this is a very common mistake, one that will plague you in grade 10, grade 11, grade 12, university it plagued me too. Remember to distribute the constant to all terms. So if I were to say negative 4 times x squared minus 8, here's what I could do, or this is when I'm not thinking straight. I go negative 4x squared, no problem. But then I go, oh yeah, negative 32. But remember, it's negative 4 times negative 8, so it's actually positive 32. So don't forget to distribute. And that actually happens in subtraction all the time. Okay, you don't distribute that negative to all of the terms. So this is just a good